Today we're talking about estimating products and quotients. So what do we mean by products? Raise your hand if you know what a product is. Mackenzie?
The answer to a multiplication
problem. Answer to a multiplication problem. And what's a quotient? Yes, Jensen, I see that hand.
It is one of the numbers in the problem.
Specifically, what type of problem?
Multiplication problem. And
division problem. It's the answer to a division problem. So answers to multiplication and division problems, we're going to estimate it. And I want to write these two things down. And I'm going to actually underline them. But we will be using rounding, which we've already done. And hopefully you're getting better at if you're not already there. And this concept of compatible numbers. We'll talk about those in just a bit. So rounding, we've done. That's taking a number and rounding it to a certain place value and then using that to add, subtract, multiply, divide. Today, what operations are we talking about?
division and multiplication.
Yeah, sorry, that's a TI. Compatible numbers. Okay, and the main concept we're going to be using is compatible numbers. Does anyone happen to maybe know what that even means? What is compatible numbers or compatibility? Compatible to something? Yeah, Jack?
You can go like back and forth between two things and it's the same.
Okay, so you're thinking like backwards compatibility, like Xbox. You can play games on Xbox. What's the new one? One? So you can 1S? X. Look at that. They got to add that letter, right? X is a good letter. Okay, algebra. But you can go backwards. You can use backwards technology in your new technology. So compatible. Anyone else compatible? Yes, ma'am. Bella?
You can trust.
So you're thinking like relationships, compatibility. Yeah, I get along with certain people because they're either like me or they complement me well. So like my wife and I, we're compatible. Not because we're the same. In fact, we are not the same. My wife is a bit quieter. I'm a bit louder. So we're compatible. Anyone else is compatible?
it has the option of doing more than one thing.
Okay, so it's multifunctional, so it can do more than just one thing. A computer can be considered compatible in that sense, or your phones, or Swivl, or the internet in general. This book, a pencil.
It can be compatible to your phone.
Yeah, it's compatible with your phone. It works with your phone. All right. What I want you to get with the word compatible is it makes things easier. Makes them easier to use with multiplying and dividing. So what I'm going to do here is I'm going to change this page, and I'm going to give you a problem. Don't work it out, please. You're going to be sadly disappointed that we're not working it out completely as it is written. So 47.5 divided by 5.23. Okay, so that's my division problem. In this assignment, you are not working this problem out. You're going to estimate the answer, and we're going to use rounding and compatible numbers. So if I'm looking at these two numbers, wouldn't this kind of be a tough division problem as it's written? I think so, like 3-digit divisor, 3-digit dividend, and now I'm going to have to move the decimal. I'm probably going to get a decimal answer. I'm not making you do this right now. What I am going to do is this. These two numbers can be rounded into compatible numbers. And there are many ways to do it. So one way that I chose was I'm going to round 47.5 to 48. Okay, is that reasonable? I rounded it to the nearest unit, or 1. Okay, but I'm also going to round the second number not to 5, but to 6. Now, would you say that 5.23 is close to 6?
Yes.
I'm not saying they're the same, but they're close. Now, why in the world that if I change 47.5 to 48, would I want to change 5.23 to 6? Like, why would I do that? It makes this problem different. Sydney?
Well, since you put 47.5 and you round it up, so maybe you want to round up with the other one so it'd be more equal.
Okay, so maybe you want to round them both up to numbers. Since you round one, you should round the other one up. Okay, we'll talk about that. That's actually something we're going to bring up here. But why? I mean, why 6? Why not 10 or 5 or 4? Okay, Elizabeth. Okay, how many of you can do 48 divided by 6? Give me the answer now.
8.
The answer would be 8 if you did 48 divided by 6. Now, if this number could round to 48, which we say it does, and this number is very close to 6, which we agree, then wouldn't my actual answer be very close to 8? Is it going to be exactly 8? No, but is it going to be close to 8? Okay, the reason we go through this process is because when I work this problem out later, not today, when I work this problem out, I can have a guess or an estimate that should lead me to a correct answer. So let's say I work this out. Let's say I work it all out, and I got this answer. Ready? 79.53.
Is that the answer?
No. What if I got 79.93 or whatever I said? What do you think? Is it a good answer?
No.
Really? Why not? I mean, I did all the math, I thought. Okay. It's not even close to 8. It's a double-digit number that is not even close to 8. Okay. But if I estimate first and then I work it out, then I know there's something I did wrong, and it's very simple. It's not 79.93. It's 7.993. So what happened in that problem? So I got 79.93, let's just say. I'm making that up. It's not actually that. It's 7.993. So which one of these sounds more accurate? I guess. Yeah, you see how they match the estimate? Okay, this helps me to do these problems. And not, how many of you have ever done this? You've worked out a hard problem, and then we come to check it out, and you got it wrong. How many of you have ever done that? You've worked out this very difficult test, quiz, homework assignment, and you got it wrong. That's happened to me many times. But you know what can help me out? You know what can help me out? Estimating before I work it out, or estimating after I work it out, and seeing if these match up. Because these two are not the same as these two. Okay, so let's look at how we're going to do this using compatible numbers. I'm going to give you another example with multiplication. So 8 times 98.24. Ooh. Am I going to make you do this today? Just like it's written? Nope. I want you to use compatible numbers with rounding. So I'm going to leave 8 alone. It's easy to deal with, right? But what do you think I should change 98.242 to make this easier to estimate? Bella? 100. So I'm going to do 8 times 100. And what's that?
800.
It's 800. That is an estimate. So 8 times 98.24 is approximately 800. Does that make sense? Okay, that's all you're doing in this lesson. And I really hope, and this is actually, here's a little confession as a teacher. I've taught math now for 7 years. Yeah, 7 years. I have to think back that long. When I was just a young college graduate, coming out of school with books on one side and pencils on the other. And I'm here to teach math. He's not getting it. But I come and I start teaching estimation, and I've done it now I've taught several classes a year, right? And I've taught for several years. I've taught this many times. But you know what? We don't use it. It's like we go through a whole lesson, maybe several lessons on this, and we don't even use it. Use it. It's for your benefit. Before working this out, just mentally do, what's 8 times 100? 800. And when you work this out, should it be close to 800? Yes. And you know what 8 times 100 is, so that's not hard. I hope. All right. Example number 1. Let's look at this problem. Oh, my. 67.45 divided by 7.6. Okay. I'm looking at this problem thinking, ugh, I'm so glad we have to estimate and not actually work it out. But you know what I also like about this lesson? You have variety. You guys think differently. You guys maybe are thinking of one thing, I'm thinking of another. You can do it. If this is the problem, I need to see your work. And some of you are like, work. All I need to see is what did you change these numbers to and what's your final estimation. So this is what I would do. So I'm looking at this number and thinking, you know what? I'm going to round this number to 70. So what do you think I should round 7.6? Maybe you're starting to think of how I'm thinking here. I don't know. Elizabeth? 7. Now, why 70 divided by 7? Because that is easy. So what's 70 divided by 7? 10. So my estimation for 67.45 divided by 7.6 is approximately 10. Okay, would anyone have done anything different? There are other ways to do it. It's not the only way. Give me another way to do it. Marissa.
Round 7.6 to 10.
So round this to 10? And then you're going to keep that 70?
And you can get 7 on it.
All right, so you get 7. All right, anyone else think differently? There are other ways. Sophie?
Oh, no, mine, it won't work.
Okay, Callie?
I did what you did, but could you do 72 divided by 8?
So take that to 72, make that 8. And what's 72 divided by 8? 9. Okay, can you do that?
But they're all in like the same like section.
Exactly. You see how my range right now is 10 to 7? Okay, so your answer is going to be around that range. So if you get an answer 114 when you divide that out, are you correct? No, you cannot be correct because all my estimations are either 2-digit or single-digit numbers. Does that make sense? Is there another way? I want to see your creativity here. I'm seeing another way. Maybe you are kind of, I don't know. John?
64 divided by 8?
Yeah, I'm going to bring that to 64. I'm going to bring that down to 8, and that gives me, look at that, in the same range, right? So all of these answers are correct, but this is what I do not want to see on your homework. I do not want to see 10 circled, that's it. You need to tell me what you rounded these numbers to, and then your answer. Make sense? Okay, after all this work, I'm curious. How many of you think you know which one it's closest to? And we have a handy-dandy calculator. Which one is it closest to? So is it closest to 7, 8, 9, or 10? So which one, who has a guess? Jack.
9.
9, he says.
8.
8. Who else says 9? Who says 8?
Me.
7. 10.
Me.
Okay, let's test it out. Carry the 5. The results are in. It is closest, not to 10, not to 7, but to 9. It's closest to 9. Who said 9?
Yeah.
The actual answer is 8.875.
It's
Closest
still
to
8.
9. Yeah, it is 8, but it's closest to 9. Now, let me ask you this. We know it's not closest to these two, but why do you think it was closest to those two? Like, what did I do in my rounding or my compatibility with numbers that made it more actual to get 8 or 9? This is where I want you to think about numbers a bit. Okay, Braden, what do you think?
Because the 72 is close, is like more, I don't know, like more, like better to use, I guess.
Better you? Okay, maybe it's better to use. It's all right. Yep, Caroline.
70 is closer to 67, and 7 is closer to 7.6. So why is it closer than 9?
Gotcha. This is where I want you to think a little bit here. Wouldn't this be considered a fraction, 67.45 over 7.6? I mean, you could write it as a fraction. Okay, the closest fraction is 72 over 8 because these two fractions, if I wrote them in fractional form, are the most proportional. Okay? Have we talked about proportionality? Not this year. We're going to get into it. You're going to see that these are most proportional. You don't just take one away and add one there. That doesn't work that way. Or you add one here, add one there. It doesn't work that way either. It's which ones are most proportional. We'll get to that. There's a way to actually think it through, but any one of those answers works. Okay, good. All right. Example 2. This time you have a fraction. Example 2 is 5/14 times 30. Oh. Ugh. Okay. 5/14 is really close to a number that is very compatible to 30. So this is what I want you to think. I tend to leave the whole numbers the same. I deal with either the decimal numbers or the fractions. So I'm not really going to change 30. I want to change 5/14. But to what? I don't know. John?
Oh, a half?
It is semi. I would take it. So if you said it's a half and you did times 3, and what's that going to be? Everybody? 15. So I would take that. I'm good with that. Another one? Yes, ma'am.
Can't you turn the fraction into a decimal and then do it like that?
Yeah, so like you change that like we did yesterday and then round that to match it. Yeah, you could do that, but I want to save you steps on that because that does take you a while. That can take you a while. Yep, Jack?
1 and then 30.
You could technically do that, right? Because you get 1, but you see how that 30 is going to be really far away from 15, so it's possible. Watch this. If this were not 5/14 but 5/15, what's 5/15 reduced?
1/3.
Elizabeth? 1/3. So 5/14 is very close to 1/3. And what's 1/3 times 30? 10. All right? Which one's the closer answer? Sophie, what do you think?
15.
She says 15. Braden?
10.
10. Or we have an even split here.
I say 10. I say no surprise.
The results are in. Drum roll, please. Thank you for that drum roll. It is closest to 10.
Yeah!
It's 10.71, and it keeps going on, but 10.7. So it's about 10. Now, why is it closest to 10? That's true. This is proportional to that more than these two are. That's it. This fraction is pretty close to 5/14, but 1/3 is closest to 5/14. All right. I will take either answer as long as you show me what you did. Do you understand? You guys good on that? All right. Let's go through some that you can try out. On page 282, and I want to see you guys. I hope you have a variety of answers because I want to see how you do. On page 282, do number 8. 40 times 2/9. We're estimating here. We're not getting the exact answer. We're just trying to see what's a reasonable answer. It's similar to the one we just did. So let's see if you guys can think it through. Do I want to change 40? No, don't change 40. What could I change to 9ths? Emphasis on 9ths. Into. Jack?
3/9, which equals 1/3.
Okay, you could do 1/3. So you would do 40 times 1/3. Are those super compatible?
No.
They're easier than 2/9, but you're going to get a fraction or decimal still. So, what do you think, Elizabeth?
I did 2/10 and reduced that to 1/5.
Okay, so 1/5. And what's 40 times a fifth? 8. That's compatible. So 8 would be an answer. Anyone else? Yes, Caroline.
I did 2 already, and that would be 1/4.
Oh. Is 2/9 really close to 2/8? And what's 2/8? 1/4. What's 40 times a fourth? 10. Anyone else do something? Yep, John?
Didn't you, like last time we did one like this, you rounded to 0, you would have just rounded 0, half, or 1, and it was the closest to 0. So couldn't you do 0?
Yes. I mean, you could technically do that. You'd get 40 times 0.
It's not the closest, but still.
It gives you a good estimate. So how about this? Do you think your answer is going to be a triple-digit number? No. What's it probably going? How many digits should it probably have? 1 or 2 at the most. 1 or 2. So that does help you out a little bit. But yeah, that's because you're making that go really far, as far down as it can, and 0 is kind of a hard number. But good understanding. Yes.
I don't understand how you estimate the decimal.
So you do this.
I mean, not the decimal fractions.
Gotcha. Can someone explain how we got the 1/5? How to get that 1/5? I have no idea. I kind of forgot. Jensen.
You kind of like estimate and use what you're thinking.
Yes. So 2/9, Bella.
Yeah.
Can that be considered very close to 2/10? Mm-hmm. What is 2/10 reduced? 2/10. So you do that. And then how in the world did we get the 1/4? That's strange to me. Sophie?
Well, 2/9 is close to 2/8 too, and 2/8 divided by 2.
Oh yeah.
2
Yep.
equals 1.
Good. There you go. So yeah, you pick whichever one you think of, and I like the way Jensen put it. The one you think of, that's the one you do. So okay, number 9. Number 9. Try it out again. Again, I need to see the numbers you round them to, so that I can make sense of your estimation. So what in the world are we doing with this one? I think this one's hopefully a little bit easier. What am I doing with this? Bella?
Oh, can I?
Yeah. Or give me what you rounded them to make them.
17.8, I got 18.
All right.
And then 3.2, I got 3.
Oh, why'd you pick 18 and 3?
Because they're compatible.
They're compatible. 18 divided by 3, 6. Anyone do something different? Marissa.
I rounded 17.8 to 20, and then 3.2 to 4. Plus it 25 by 48 times.
Okay, there you go. Both of those are legitimate. Emma Grace?
We round 17.8 to 18 and 3.24.
Okay. Look at that. Are those acceptable?
Yes. Can't you do one more?
Sorry?
Can't you do one more? 15?
Oh, you want to try one? Go ahead.
15 divided by 3.
15 divided by 3, and that gives me 5. So you both got the same answer, doing it differently? Fine. How many of you feel semi-comfortable with this? Semi to very comfortable. How about that? Semi to very comfortable. Okay? And listen, you know how you get better at this? You just keep practicing. I can get better at this because I'm looking at which one's better. Which one's the best estimate? What do you guys think? They're all good. Is it closest to 4, 5, or 6?
5.
6.
Yeah, I was going to 2.
All right. Whatever you guess, that's fine. Let's see. Yeah.
It's not following. Well, we turned it off.
Oh, yeah, and it's okay because it's been on the board, but I Swivl. Okay.
It found you.
Oh, there it goes.
Dun, dun, dun. It was almost a tie between not 4, but 5 and 6. It's 5.56. So what is it closest to?
6.
It's a little bit closer to 6. So it's between 5 and 6.
What a legitimate way to say that is like, it's 0.2 from 18 and 0.2 from 30, so that's like closer than.
0.2 from 18.
Like, and then it's 2.2 from 20.
Oh, it's 0.2 from 18 and 0.2.
So would that work, everything?
It's all about proportionality. So it works on that one. It does. All right, another one. If you guys can get this one, you guys are good.
Yes.
Number 10. Number 10. Oh my. Wait. Oops. That was a harder one. But if you get this one, you're good. Number 10. 5/12 times 44. Ooh. I know 2 of you are very confident in your answers. 3 of you are getting, 4 of you are confident.
Max is very confident.
Max, what'd you do?
6/12 times 44.
All right, what's 6/12?
1/2.
So you said 1/2 times 44, and what's that? 22. How many of you got 22 as your estimate? Okay, I think that's I would think that's probably the easiest one to do. It's really close to 6/12. 1/2 times 44, 22. Did anyone do something different? Which is okay. Yeah.
I did 1/2 times 40.
Okay,
20.
so technically I'm going to accept that. That's fine. I would say don't change the whole number, but you can. It's an estimation. But I wouldn't recommend it on most problems. Sophie.
I have a question.
Yep.
So when you, like, you did 12, and then you get 1/2 times 44, and you got the answer 22, are you really, like, dividing the bottom two to get the answer?
No, you're multiplying.
And
So oh, I see what you're saying. So you're doing 1/2 of 44. And this is the cool thing. Multiplying by half is the exact same thing as dividing by 2. Same thing. So what's 44 divided by 2?
22.
And what's 44 times 1/2?
22.
Yeah, so get that in mind. And that's actually going to be helpful later on. Yes, Bella?
Did you do something with 11?
What'd you do?
I did the first one. But couldn't you do something with 11? Because
I think I kind of see what you're doing. I would do this. I would make it 5/11. Then that would be 4 times 5 is 20. So, but that's a little bit more steps. Yep. 1/3. Okay, because it's close to 4/12. 1/3 times 44, and that gives you a fractional answer. But I mean, it's still an estimate. All right, example 3, and then I'll give you your homework. Example 3 on page 281. Let's read this real quickly. Kelly found a part-time job working at the Discus record store. What's a record store? It's where they used to sell records for BC or AD. Okay, it's a record is basically the precursor. That means it came before cassette tapes, and cassette tapes came before CDs, and CDs came before downloading it digitally. So that's a long time. Yeah, now you can do it on your own.
Now we can just make tracks.
It's a vinyl album. Oh. So yeah, that's what we're talking about. All right. Kelly found a part-time job working at the Discus record store for $5.85 an hour. The manager told Kelly that she will probably work about 7.5 hours each week. She will be paid every 2 weeks. Estimate Kelly's pay before taxes are deducted. So they're going to take away taxes, so we're ignoring that for now. But how much is she making an hour? $5.85. How many hours is she going to work in 1 week?
7.
And how often is she going to get paid? Every 2 weeks. So how much is she going to get paid for every check? It's $5.85 an hour for 7.5 hours for 2 weeks. Okay, they're not asking you to work this one out. They're asking you to estimate. And actually, the way the book did it, I'm going to do it differently. What do you think 5.85 should round to?
6.
I would say $6. And what do you think 7.5 should round to?
8. Because it's
Okay, I'm going to go with 8 for now. And then 2 stays 2. What's 6 times, and here, you could do 6 times 8, or 8 times 2, or 2 times 6, and then times the third. What do you get, though, regardless? What's 6 times 8?
96 times 8 is 48.
6 times 8 is 48 times 2. So she's going to get, every 2 weeks, she's going to get about $96. Yeah, and this is like 20 years ago. So you can't get a job for that amount. Oh. Uh-oh.
supposed to do a week?
No, every 2 weeks. But hey, they got $100 every 2 weeks.
This was an estimate.
Oh, there you go. So I'll take both of them.
Ooh, how do you get there?
How do you get taxed?
So tax, you're gonna lose like 20% of that. So she's actually gonna get paid $80, roughly.
Wait, so they did it where they didn't do it too. And so they did
No, you.
6 times 8, and then they did 48, and then they did 48, and they rounded back.
So, and then they did 50 times 2 is 100.
So it's a little confusing.
They did a little more rounding. That's okay. All right, guys, your homework tonight is 15 to 31 odd.
It's going to be plus 45 and 46.
Close.
Oh, 37. I was really close.
37, 44.
And that's pages
Still recording.
280. That's okay, because they'll get our homework. 283. So 282 to 283.
Mr. A. 40 to 37 to 44 is that all?
All.